Hi everyone, once again welcome back to the channel. In this video we are going to see and set up the configuration of the EFK, Elasticsearch, Fluent Bit and Kibana. So basically in this project we are not using the log stash. Why means I'm going to show and explain why we are not using the log stash. Okay, so here in this project the Elasticsearch is mainly going to store your index logs. Okay, and here you can see it stores an index logs for the faster search and analytics. The role is going to play is act as a database, is storing the logs into the Elasticsearch, and one of the persistent volume we are going to give this Elasticsearch. Basically the Elasticsearch act as a stateful set. We are not using this one as a deployment or report or replica set. We are using as a stateful set because we need some exact name of the host name, right? Like a database. So that's why we are using the stateful set, not the deployment. And the Fluent Bit is mainly used for the collecting logs from the Kubernetes pods and the nodes. Is going to collect the data of the logs via the related to the pods and the nodes, and is shipping the logs to the Elasticsearch. Typically it used as a daemon set. Each node have one of the Fluent Bit daemon set is going to deploy each node. The Kibana is basically used for the visualizing the logs stored on the Elasticsearch. The Fluent Bit only uses for the sending the logs to the Elasticsearch. Elasticsearch stores the logs, and Kibana is only for viewing and visualizing the logs. We can also filter it out the required logs in the Kibana. Okay, and the function, the Kibana is basically used for the deployment, not the daemon set, not the replica, not the stateful set. Kibana used for the deployment, and it uses the load balancer to access the Kibana to the external via the web browser. Okay, so here in this project we are using the Fluent Bit instead of the logstash. Why? It's a lightweight. As seen in the table here, it's a small footprint, ideal for the edge nodes or sidecars. Basically the logstash is heavier, it consumes lot of the CPU and the memory. That's why we are using the Fluent Bit. You can use the logstash, but it consumes a lot of memory. That's why for the lightweight we are using the Fluent Bit. Kubernetes native, easy to run as a daemon set. This is also we can use the by using the daemon set, but it consumes the more resources per node. Okay, so in the Fluent Bit it has only have few basic filters. Okay, and the for logstash have the multiple and advanced level of parsing croc. Okay, so it's have multiple filterings. So easy to set up, simple Helm chart. It's have simple Helm chart. So it's required some pipelines to input output filtering. We have to configure it in the logstash. So here also we are doing the some pipelines input output filtering also, but this is a simple filtering we are going to use in the Fluent Bit. So instead we can also use the multiple logging tools in the Kubernetes. Basically we are executing this one EFK Fluent Bit. So you can also use the Fluent D also. So if you like to do the logstash also you can use. And one more tool is the Promptail, Loki and Grafana. You can also use this type of the logging monitoring tool also. So before starting this project, so we have to install some required common packages. So for this packages installation, my system is Ubuntu. For some of the engineers don't have the Ubuntu, So that's why I'm going to create one of the EC2 instance in the AWS console. So just skip out this 10 minutes. In this 10 minutes, I'm just going to installing the required packages, AWS CLI, kubectl, and the EKS help, and the configuration. Just skip out the 10 minutes and come back. So for the who don't have zero knowledge in the Linux operating system, so this is video for to setup for the required. This is simple setup. Just type EFK logging EC2. So I am selecting Ubuntu. So all the commands works only on the Ubuntu flavored distribution. So I am selecting the Ubuntu. If you like to do the CentOS, we have to change with the apt to DNF or M. Okay, this is enough, but I'm going to select some much more memory here. T2 small, T2 micro is enough for this project, and create one of the key pair if you what you have. And I'm going with the default one. We are not accessing or doing any stuffs here, just we are configuring the packages. And memory is 8 GB is enough for this project. Click on the launch instance. And one more here, in this project we are not using any external EKS commands to provisioning the cluster. We are using the YAML file for the Kubernetes EKS cluster creations. This is one of the another option to provision the cluster. So everybody seen the command line of the EKS Some people know about the Terraform while provisioning the Kubernetes. Here we are using the this file. This file is going to provision your cluster. Okay, so now one of the is provisioning. Just try to connect it and copy this one and go to your the path. If you are using the Windows, you know guys how to connect this on the machine. Just connect it. Sorry. Actually this is a simple setup, no need to worry about the all the command what I given here. Just wait until it should come to the check 2x2 check, sorry 3x3. Yeah, okay, now update the machine. Yeah, is updated. Now copy this command. In this command we are rinsing some basic utility, bash completion, wget git. Git is essential for this project. And don't blindly copy paste all the commands what I given here. Just observe what the command I given and what it required. Okay, and here one more we have to install the command is AWS CLI. First I'm going to execute this one. So we did not done this right. Okay, let's first go to this referral AWS CLI installation guide. This is the guide to set up the AWS CLI based on your architecture. If you are using the Linux, here is the command, you can get it. Otherwise, if you are using the Windows, this is the command, and this is if you are using Mac. So always go with the official documentation. Don't just copy paste the commands what I given in the readme file. It may broke in the future. Okay, so AWS CLI is going to help to configure the AWS console in your terminal. So this is one of the done, and just execute this bash completion. Done. So next command is kubectl. So here again I am going given the official documentation. Just go here and search the commands according to your architecture and install it. Okay, here you will get the in the left side installation tool. You can also filter it out. Let's copy this this one, just copy one by one, don't copy paste at the same time. And copy this one. Yeah, kubectl. Okay, why we are using the kubectl? So we using the kubectl to get the details about the deployment, pods, services, ingress. We can also describe the things of the pods, deployments, and even more we can do by using this kubectl. We can also get the details about the nodes and much more we can do it by doing the kubectl. That's why we have to install the kubectl. Kubectl mainly used for the related to the pods and deployment services, not the creation of the cluster. For the creation of the cluster we are using the EKSCTL. Okay, for the EKSCTL, here again I am given the command where it is this done, right? Yeah, kubectl is EKSCTL is basically for the Amazon. Why this is different means this is going to provision your cluster, is not provision your pods or deployments. Okay, the command is similar, the same. I'm just going to copy and pasting it here. Some people have too much of confusions in the kubectl as well as the EKSCTL. So you have to know the difference between the two things. Okay, maybe the problem. Okay, EKSCTL is installed, and Helm is we are installing some required things of the Fluent Bit and Elasticsearch. For that related pod creations or DaemonSet creations, we are using the Helm. Okay, we can also use the basic what we are done in the Kubernetes manifest file, but if you are using the some application load balancer of the AWS, on there we have to use the Helm and Argo CD to install your AWS means you have to install the via the Helm on. Okay, so we done everything. So again now we have to take the one of the access key and the secret key. To get that access key and secret key, just leave this one and this one. Okay, and move back here, go to the IAM. In the IAM I have one existing one, so again I am going to creating it. So make sure you have the administrator access. This is not a root user, this is a normal user account. It's have the administrator access here, and just click on the security credentials. Here I have one existing one, and again I'm going to creating for the new one. Create access tool, access key, click on the command line interface, click on the I understand, click on the next, EFK, create access, and now you will get two things, access key and the secret access key. Just copy this one and move back to the command line. Now type AWS configure, hit enter. So you have to paste it here, hit enter, and the security, just copy it and enter. And the default region name I'm going to give AP South 1 JSON. The format output is I'm going to give the JSON. Done. One of the AWS configuration we did it, done. So now we have to clone the repo, right? The repo link I given here, the same thing, the repo is log EFK AWS EKS. The same thing is here. If you don't have the confidence, just copy this, the link repo, and where I left it here, yeah, and make sure where the path you have, git clone and paste the link, hit enter and clone it. We cloned it, right? So move to the log pwd, so to create the cluster, this is the file to create the cluster, EKSCTL create cluster -f. So this is the command to create the cluster. Okay, so is going to creating the cluster. It takes approximately 50 minutes to create. So let's going to check what are the things is happening. Okay, just copy this one. In the local machine, I'm going to just cloning it. I'm not doing any things in the local machine. So here you guys know about the thing, right? So here by using the YAML file, manifest file, we are giving the kind as a cluster config. Here the name, the cluster I am giving the my cluster. Where this cluster should be created, it should be created in the AP South 1. Okay, the version of the cluster is 1.33. I'm giving the exact cluster version here, 1.33, and you should be know while creating the cluster KTS release. So each time the Kubernetes is going to update their version. So this is the release note you can see in the browser. So currently the release version, the history is 1.33. so you have to make sure and you have to know about this versioning of the Kubernetes. Okay, so each time where you creating the version of the cluster, you have to define the which cluster version you have to set up. So in the tags, this is a normal basic details I am just given here. I'm giving the availability zones. In these 3 availability zones, the nodes going to creating it. I'm giving the OIDC is true, so is going to create the service account related to the add-ons and related some services of the CNI CSI, like that. Okay, here I'm giving the managed node groups in as a name of the worker node groups. The instance type I'm giving it T3 large, maybe is let's cross check it here only. Go to the instance type. What is T3 large? So T3 large have the 2-core CPU and 8 GB RAM. So basically we are given the 3 nodes, should be maintain 3 nodes in 1 node each availability zones, and maximum you can scale up to 5. Okay, and it should be work in the private network. I'm giving the true. Each node we given the 20 GB of the EBS volume. Otherwise, if you not define this, what will happen? It's going to take 80 GB of the EBS volume. So here the basic thing we are given, we can I given the autoscaler is true, and external DNS we given the false, and EBS we given the true, because we are attaching one of the persistent volume to the Elasticsearch. So that's why I given the EBS true. So these are the basic details I given, and ALB ingress I'm given the true here. Why means we are accessing the Kibana via the web browser, so that's why I given the ALB ingress true. This is the basic details about the creating the cluster. So it takes approximately 15 minutes. We have to wait for it. Yeah, the cluster is successfully provisioned. Let's try to check. So we got a 3 instance here of the clusters. So each node, it is in the independent availability zones. You can check out here the 1A, 1B and the 1C. Okay, and let's check the cluster EKS. So here the cluster is active state, and you can observe one thing here. We gave on the 1.33 version. The current release version in the market is 1.34. So you have to mention in the manifest file what version you have to give. Okay, this is the main thing you have to observe. So you can also upgrade via here to 1.34. okay, so now let's move on to the topic. We created the cluster and we have to update the cluster details to the kubectl kubeconfig. Where it went? Just copy this one. This is basically nothing, simple command is this command just going to update the kubeconfig about your cluster name and where which region your cluster is up and live. So we added the context here, so you can also filter it out how many node groups and each node group in our which availability zone is provisioned. So you can list out here. Yeah, one node is 1A, 1B and the 1C. By using this simple command, you can filter it out by using the grep. So we done everything. So we have to install one of the EBS driver. So why we need this EBS driver? So we are provisioning the volumes via the EBS for the Elasticsearch. So that's why we have to install this one of the DaemonSet of the EBS CSI. So just copy this one and make sure the release version is 1.44 version. This is the AWS EBS driver version 1.44. Just copy the command and paste it here. The command is simple. Yeah, now kubectl get, this is the DaemonSet, not the deployment or anything. DaemonSet EBS CSI node system. So the desired three DaemonSets is up and running. So let's get the controller. So 2x2 controller is also up and running. Okay, you can also see what CSI node going to do. DaemonSet on every worker node for attaching and mounting the EBS volume. This DaemonSet CSI node is going to create the pods each and every nodes, and the CSI controller uses this as a deployment for the volume provisioning and lifecycle management. Okay, and we did it. Now we are moving forward to the EFK. So first we have to install the EFK. So here, before starting the EFK, we have to create the one of the namespace. The namespace is simple, EFK logging. See, the namespace I am giving, EFK logging. Just copy this one and paste it in here. Yeah, the namespace is kubectl get namespace. EFK logging is just created. Okay, now we have to add the repo of the elastic. This is the Helm chart of the elastic. We are going to adding via the Helm. Just copy and paste it. We added the repo of the Helm. So now here we are creating the elastic StatefulSet node DaemonSet. Just copy this one, and before doing that, let's create one more here. Just copy this one. Let's observe what will happening on that machine. kubectl. First I will going to update the context. This is the context for the namespace. Modified kubectl get pods watch. Okay, no resources is there. Okay, now just copy this one and paste it here. Here I am setting the resource limit and limitations. Why means it consumes lot of memory and resources, so that's why I'm set the limited. The command is just simple. So release Elasticsearch does not exist, installing it now. So you can see in the below the Elasticsearch master I0. This is one of the StatefulSet is creating. So it takes approximately 2 minutes. So one more thing I have to say, for this project you have to spend at least 20 rupees or 20 cents or 30 cents you have to spend for this project, because we are using 3 nodes and the cluster and some data we are using. That's why we have to pay some amount, the small amount, 15-20 rupees we have to pay it. And let's check one of the here. One more thing. Yeah, click on the volume. See here what will happening. The cluster nodes, worker nodes have the 20 GB of EBS volume or each node, and the 30 GB. This 30 GB is attached to this one of the node. 50 in this node, the last node, see 3350 is attached. This is the 30 GB of the provision volume for the Elasticsearch. Done. So the one of the StatefulSet of the Elasticsearch is up and running. We just created. Okay, So to get the password and the username, here they given to get the password. This is the command to get password. So the command, everything I just compressed here in this readme file. To get the username, just copy this the command and paste it here. So this is the username of the Elasticsearch. Just copy this. And for the password, copy this command and this is the password. Just copy this one and paste it one of the notepad. So we got the two things, right? Okay, and now we have to install the Kibana via the Helm. Just copy this one and paste it here and see the below what the things is creating. Here the command is simple. We are updating the Kibana via the Helm, and in the namespace of the EFK logging we are creating the Kibana, and the service type we are exposing to the external by the load balancer, and one replica of the count if we are going to creating it. So hit enter and see here, this is the replica set of the Kibana is installing. These things are the one parts is installing. Done. And now we are going to installing the we are provisioning the Fluent Bit. So before doing this one, we have to update the password inside the Fluent Bit YAML file. So do that, just copy the command here and move back. Let's complete this one. So Kibana is also successfully deployed. Now move to the folder, the path. Okay, here nano 1 dot Fluent Bit. This is the YAML file of your Fluent Bit. Just I'm going to close this one, otherwise. Okay, here what we have to do, just replace the password, move below here, where it left. Okay, let's search it here. Password, yeah, password filter, input filter. Input, yeah, we got it here. We have to replace the two things here. The one thing, this one only. In the output section, just replace this password with a new one. What was the password? 5. And here the same flow is there, just replace these two things, just save it. If you find difficulty in the nano editor, just edit in the Visual Studio, just type the pwd pass wd. So here the two things you have to replace the password here. Here you can see you have to replace this portion and this portion. Okay, once you updated just apply kubectl, sorry, not this command. After this is the command. Okay, just hit enter. Watch kubectl get parse. See here the daemon set of the Fluent Bit is creating in each node. Each node is going to collect the logs and sending the logs to the Elasticsearch. Okay, let's describe it first. The thing. So I just described the Elasticsearch master IO. The thing is it is in the StatefulSet. Let's describe it of the Fluent Bit. One of the Fluent Bit is enough. CV. So it is in the DaemonSet and Kibana. So it is in the replica set. Okay, you have to check these things. Done. Let's move on to the next. Let's take the ALB URL. So when you type this command kubectl get svc, so this is the classic load balancer address of your Kibana. Just copy this one and go to the browser, just hit enter. Sorry, now you have to give the port 5601. When you give on the 5601, you will get a like this login dashboard. So just copy the username and as well as the password. Login. Okay. So the data is nothing here because we did not added any logs matrix. So for that, just click on the discover. In the left side you will see this this one, discover. Click on the discover and create the data view here. In the name I am giving EFK logging demo. The name I am giving. If our index pattern, just copy this one, the log stash, paste it. Sorry. So in the timestamp field I am selecting the @timestamp. Click on the save data view to the Kibana. So here you can see the left side the details about the containers pods. The one thing you have to check in this file what I am given here, this is the filtering output and inputs. Okay, where I left, yeah, this is the Lua scripts. In the Lua scripts what I given, I just excluding this namespace EFK logging. It excludes only EFK logging and it gets all the logs about the other namespaces and pushing to the Elasticsearch, and we are visualizing via the Kibana. Okay, here the input is the path var log container dot logs. All the details about the container logs is going to fetch. Filter is kube.store. The output is sending to the Elasticsearch master via the port of the 9200 and the username is Elastic and this is the password. Okay, that's it. That is a simple one. The daemon set the volume is going to check on the here. Actually the image of the Fluent Bit uses this repo, the fluentbit.io, Fluent and Fluent Bit. This is the image of the Fluent. Just copy this one and paste it in the console. So it's create the 10 plus microservices. kubectl watch get parse and the namespace microservice. See, all the microservices get deploying. So let's try to refresh here. So it takes some time to get the details. So when you refresh the Elasticsearch, the Kibana dashboard, so you can see it. The types is right now is 51, and you can see the details about the logs, what are the things is created in the Kubernetes. So what are the images just pulled, and details, logs, everything is going to see in the below. You can also filter it out by using this some KQL syntax. And the left side I am just going to show one of the simple to see how the logs is going to do. I am selecting the left side, the currency, click on the visualize. Here you can see number of charts is available, so you can select it what chart you like to watch. And this is the one of the microservices logs. Here USD, GBP and JPY, Japan, Canada, and these are the currency types is going in the microservices we have. And what we have to do, let's take it, kubectl get svc in the namespace of microservice. So this is the microservice of the load balancer address. Just paste it here. So this is the microservice. I am going to selecting the euro. So it's going to convert the price here, and let's try to refresh. It changes according to the logs. You can see this is the basic simple thing. You can explore it in a detailed way. Okay, you can see the timestamp on which time frame we got the number of logs. You can see it by using these candlesticks. Okay, and the load generator. And one more thing, for this project I did this project to do this one. This is my website arishanshetty.github.io. in the left side you can see the project card. Click on the project cards. Here you can see the project. This is the project. If you find this project, means where I kept it, yeah, select the DevSecOps and click this card, and you will find the links here. You will find the YouTube link and the GitHub repo also here I given. In this project I covered the 11 Jenkins pipeline. Each Jenkins pipeline have a different security scans, and you can see in this project we use the 5+ programming languages. Each microservices have different independent programming languages, and for dependency scanning we are not only using the WASP, we are using the different dependency scans. For the Golang we are using the Go value check. For the Python we are using the Python safety. Okay, don't miss out this project. So this is the project of the EFK, Elasticsearch, Fluent Bit and Kibana. So you can later explore it out, like to see. So let's clean up the machine. To clean up this one, left kubectl get pvc. Yeah, we have one of the pvc here. First let's delete the Elasticsearch. Okay, first let's delete this Fluent Bit. Later we do it. Yeah, Fluent Bit is done, and let's uninstall Elasticsearch. Now delete the pvc. Now why means, if you not deleted this pvc, it consumes your amount. That's why we have to delete this one. kubectl. Okay, copy this one and make sure it deleted in this web console dashboard, and 30 GB is not listed here. Otherwise, if you delete the cluster but the provision of the 30 GB is it is in the unavailable state, that on that time you have to pay the amount. Done. And now this is okay. Now just delete the cluster. Just copy this one and paste it in the console. Left. The command is simple: EKS delete cluster. Forcefully we have the details about the cluster details, right? Just hit enter. Is going to clean up your resources of the node groups as well as the cluster. So it takes some time to delete. Okay, I'll leave it here. Yeah, the cluster is created, and make sure all the instance is terminated. Yeah, and the cluster is listed empty. And one more thing, you have to check the volumes. Make sure you have the one. This is the custom created instance, right? So that one also we are going to terminate it. Okay, go to the IAM. Users, security credentials, and delete. 2 hours ago we created, deactivate and delete. Yeah, successfully done the project. And refresh here. Deleted and the snapshots. Nothing. Okay, I hope you enjoyed the video. If you like this video, like and subscribe the channel. Once again, thanks for watching the video.